I'm super excited about this next speaker. Reading her book, it was before I even really got started with Kessel Run. She actually had an excerpt of the first 3 chapters that she made available. It didn't get published till 2 years later. I lived by those 3 chapters, and they've been hugely influential in my journey. Kessel Run, a lot of the DoD transformation work, and all the successful organizations that I see across federal all have some of these like understandings of cloud-native patterns. So I'm excited to bring Cornelia Davis up to the stage, now an Amazonian, but also author of Cloud-Native Patterns, and somebody that I just really look up to and inspires me, so thank you.
Oh. All right. My goodness, is it good to be here. And thank you so much for those kind words. Now, before I jump in, and I will introduce myself for those of you who don't know me in a little bit more detail, remember the picture that when Bryon and Angel were up here earlier and they showed you're only left with, I don't know, 20% or 120 controls. And there were hundreds of other controls that were taken care of by the platform. That should be enough for you all to understand that it's a platform that has all of those other things that you saw in the stack. Now, I'm not going to show that same picture. Do refer back to that picture. But what I want to do today is show you lots of other reasons, not just the controls. That should be enough, but I want to show you other reasons why the platform is valuable. So quick background, I am the opposite of Gene. I did not identify as an ops person. I identified as a dev person until I started working with platforms. I've been working in the technology space for 30 years, actually. Web architectures for 20 years, did cloud native for more than a decade, although we didn't call it cloud native then. I worked on Cloud Foundry, which was a fantastic PaaS, still exists by a different name, still part of VMware. And then before I left Pivotal, in the last probably 3 or 4 years before I left Pivotal, and then a couple of years afterward, I started to get super involved in Kubernetes, which also forms a foundation. You saw that on that same slide that Angel and Bryon showed. Now I'm working at Amazon. I made a bit of a shift. I did not go to AWS. I work in Alexa, natural language processing, and I'm working on forming platforms for natural language processing. We are not in the platform era in NLP, I can tell you that. So this is an oldie but goodie. This is one of my favorite slides. You can see at the bottom that this was published from a short O'Reilly article, and it's still up, I just checked last night, from 2007, so a long time ago. Let me explain what's on this slide. 2 different organizations. They both start on day 1. They want to create, they have a new idea, they want to create a new bit of software and bring it to market. On the left-hand side, you can see a fairly traditional trajectory. They spend a lot of time, and oh, by the way, what you can see here is the amount of time, on the y-axis, is the amount of time that they've spent on ops, on operations. Now, any time that they're spending on operations, they are not spending on feature creation. So that's the thing, that's the key to understand. So as you can imagine, they're starting from scratch. They have nothing available. Way back when, they had to rack and stack hardware. Now you can use cloud. We just heard about that. But even using cloud, in the beginning, you have some setup time. You have to set up your identity and access management groups. You have to set up some automation and those types of things. And both those companies spent a lot of time up front. Then they both dropped off on the time that they spent on operations and started doing feature development. And then they brought their product to production. They deployed it to prod. And now, on the left-hand side, you see that their operational burden went back up. And on the right-hand side, it stayed flat. What's the difference there? And this was all the way back in 2007. There were some organizations that had already figured that out. Well, what they figured out is if they set up their operational environment in such a way that they can, in fact, keep it relatively flat, even as they go to deploy to prod and scale in prod. So the difference between the left-hand side and the right-hand side is platform. So before I start talking a little bit more about the platform, let's step back and talk about, and we've been talking about this all day, what are we aiming for? Well, we're aiming for short and frequent feedback cycles. We're aiming for doing experimentation. We heard a lot about the value of autonomy, the fact that personnel and software components need to have a certain level of separation to be able to allow us to operate quickly and get ideas out to production quickly. And then we need deployments, and not deployments into a staging environment. We need deployments in production frequently. In fact, we want them continuously. Now, that's not enough. We've also heard that there's a whole host of other things that we're aiming for: security, compliance, fiscal responsibility. We don't want our costs to go completely out of control. So we need to balance those things. The things about, oh, we want to act quick and get out there quickly, but oh my gosh, we have all of these concerns. And by the way, even though I was so lucky to spend the last year of my pivotal time while I was at Pivotal Software working with some of you all, and I got a chance to go to Kessel Run, and I met Bryon, and I met Lauren, and I met various other folks. I have spent most of my career in the last 20 or 25 years in the commercial space. Being here today is sobering. It is humbling to realize the constraints that you all have in this government space. They are significant. And so my hat off to all of you. So I'm going to start all the way back to what deployments often look like. They maybe often looked like this in the past, but the reality is that deployments often look like this still, even today. We have all of these organizations from application development, then we have to do some testing, and we have to prepare data, and then we run the tests, and then we do some change control, and then we finally deploy things to production. And it generally goes a little bit like this. The app dev team creates its artifact, it throws it over the wall, then we have to schedule the testing environment, and then it keeps going on down the line. And that is something that cannot happen in a few minutes, which means that one of these deployments cannot happen in a matter of a day, a week, or probably even a month. It just takes too long. Now, I want to focus in. I'm going to share a few stories over my career working with organizations that have moved over into a DevOps environment. And I want my first anecdote focuses on these three bubbles. It is all about that I'm code complete, I want to run some integration tests, and then I want to deploy to prod. Now, this was a particular organization. It was a retail. So they said, hey, we need a platform. We need a platform to help us in this test environment that's happening in the center. It was a very large retailer here in the United States, and here's what their platform looked like. It was a Java server farm. Actually, Marshall used exactly the words that they used for me earlier. It was a Java grid. It was actually what they called a Java grid. And that Java server farm, because all of their development was in Java, was the environment, and it was configured as an exact replica of production. Hint, hint, spoiler alert, that's a fallacy. We'll talk about that more in just a second. They did have some automation to initialize things to an initial state. It was kind of sort of there. Initial state, it turns out, is a little bit different potentially for each organization. We'll talk about images in just a bit. And then the developer workflow looked like this. They had to schedule time on the servers, so they had to ahead of time say, hey, we need the servers for these 3 days to run our tests. Then they had to have Patty, and names have been changed to protect the innocent. They had to have Patty prepare the data. Then they had to run the tests. And then, by the way, their 3 days was over and their time expired. Done or not, doesn't matter. Your time expired. And all of the above was required to get to production. So you know what happened? The Java server farm was pretty popular. So if you wanted to schedule time for testing, it was at least 6 weeks out. As soon as people came on board and they were required to use this as the test environment, then it was difficult to get testing. So imagine you're code complete, or you're not code complete and you're smart enough to schedule in advance, but now you either cut it too short and now you're trading off quality because you want to get your testing window is tomorrow and you're not code complete yet, or you're code complete and now you're scheduling and you're 6 weeks out before you can test. We heard plenty of those stories already today that is not an efficient process. It took Patty a full 24 hours or a full day or maybe 2 or 3 days to set up that test environment. So remember when I said automation to schedule an initial state? Well, that initial state didn't actually have the data that you needed to be able to do the processing. And then, of course, your time would expire. If you were done with testing or not, it didn't matter. Your time would expire. You'd have to get back at the end of the line. This is what they called their platform, and they were very, very proud of that platform. Now, this was many years ago, and it was a good achievement, but we can do better, and we'll talk more about that. I come back to this picture because remember that comment about the exact replica of production? Well, there is no such thing as that, which is why we still have this department, which is the change control department. And so even though we have been through this test environment, it was an exact replica of production, we still needed to go through all sorts of hoops to guarantee that things, air quotes around that as well, that things couldn't go wrong in operations. So we need a platform, but okay, maybe not this platform. So what platform do we need? And this is a picture. These blue boxes, get comfortable with them because we're going to spend the next 20 minutes seeing these blue boxes over and over again. We have the notion of we need a platform, and then we have the application teams, the developers, who are building on top of that platform. They're consuming the services that are available to them in the platform. Now, you will see, despite the fact that it's not a coincidence that when Bryon was introducing me, he was talking about self-service. Yep, you can see that that's the headline there. Self-service what? Well, we want to be able to do self-service provisioning, observability, corrective actions. You need all sorts of things that you need to be able to self-service. You also need to have the right abstractions. Now, I agree that developers need to know a bit about the infrastructure, but do they really, really need to know about ephemeral ports? Maybe not. Maybe we can take care of that for them in the platform. And by the way, if you don't know about ephemeral ports, find me afterward. I'll tell you the story about how I learned about them. I didn't know what they were either as a developer, and I learned the hard way when we had an outage. So maybe the developer doesn't need to know about the low-level details of some infrastructure. So having the right level of abstractions to optimize that whole flow, that's also an important part of the right level of platform. And then you also saw it on the earlier slide that I referenced, tenant isolation, and there's so much more. Now, I won't belabor it, but I do want to say it's not just the APIs, because what we're talking about here is once we've established APIs, and kind of like the formal contracts, this also implies a whole bunch of behavioral contracts. So there's the contracts on how the platform team interfaces with the application teams and the application developers. There's all sorts of other behavioral contracts that are there as well. So I'm talking about a contract here, but I'm talking about more than just APIs. But there's absolutely a boundary there. Now, to sum it up, I just want to talk about those two personas. And by the way, I thought it was really great when Bryon and Angel were talking about this. They were talking about the application teams and the platform teams. I am willing to bet that there are some folks in the room who aren't familiar with the concept of a platform team. So I'm just going to sum it up really simply in this one slide. For the most part, I'm going to be talking about the developers or the application teams for the rest of this conversation. And again, what we want to do is we want to enable those teams, those application teams, DevOps teams, because they're not the old school developers where they're throwing their code complete over the wall and somebody else operates it. They're doing their own operations. That doesn't necessarily mean that they're racking and stacking hardware or even taking care of VMs. We want to enable those DevOps teams to be able to release frequently, be confident in those releases, and operate their cloud-native applications very effectively. So those are the developers, and you'll see this persona, happy-go-lucky developer, right? And that platform delivers efficiencies to be able to do those things. But then we have the platform team. They're the ones that have the really hard job: security, compliance, cost effectiveness, all of those types of things. What they're doing is, again, I'll refer to the slide that you saw earlier, where so much more was baked in, all of those controls were handled. Those are the experts that are maintaining security, compliance, cost effectiveness, and all of that in the platform. And that's the platform team. And that's who we heard referred to several times in the earlier talk. Now, I'm going to focus mostly on the developer, but I promise I will not forget this persona. We'll come back and show a couple of their benefits as well. So again, I'm not just talking about developers, I'm talking about app teams and DevOps, and I just want to explode in on this. So let's look at a few of those things. Let's drill in on self-service. Now, I want to share with you another anecdote of what self-service is and isn't. And really, the punchline of this is that you have to be very careful where the contracts are. So the developer is responsible for the application, and they're consuming the platform. A number of years ago, when I was working with another organization, they had come to this conclusion. And they had a team, they had a platform team that was building out a platform, and it was a self-service platform. The application teams could come along and say, hey, I need something. And what they were served was they were served infrastructure. They could go, and this was early days. AWS was out there, but in the enterprise, they were still kind of baking their own, using their own data centers for the most part. So it was a little bit of an IaaS as a, infrastructure as a service. And so they had published that. But then what happened was when they deployed it, because they hadn't quite gotten the contracts right, because they wanted the platform team to have a certain amount of control over the software that was already installed on the infrastructure as a service, they did not give the developers access to those VMs. So they were able to give them access to deploy things on there. But for example, when there was an outage, and the application teams needed to get to the logs were available in a file system on that infrastructure as a service. So what did they have to do? They had to file a ticket with the platform team to get their hands on the logs. This was more than 10 years ago. So it was way before we had really optimized those PaaS contracts. So the important thing is that you need to make sure that you maintain that contract, those boundaries there, so that what the developer needs is a complete set of the things that the platform is providing. It's not that they get part of what they need, self-service provisioning, but not self-service observability. So you need to be super careful about those things. And all of those things are baked into a cloud-native application platform. So what I'm coming down to there is I'm talking about what are the units and what are the contracts around those units. And so, yes, those of you who know me, I'm a technologist. I'm going to talk about containers for just a moment, because it turns out the containers really have changed everything. So for those of you who maybe are not familiar with containers, you're familiar with infrastructure as a service. You get a virtual machine. It has an operating system on it, a whole bunch of software on it, and then you deploy your software on top of it. What we've done with containers, the royal we, I had no part in this, but what started as Unix containers and now Docker made more accessible and then other things platforms like Kubernetes and Cloud Foundry have made even more accessible is the ability to use containers, where what we can do is we start with a virtual machine that has a bare bones operating system on it. When I say bare bones, I hope all of you are thinking, oh, bare bones means that I can make it as small as possible and shrink the security attack surface. Thank you, attack surface. So that's what I'm doing with that host, that kernel on the operating system. Then the dotted line box that you see in there that says OS image, runtime layer, and application layer, those are all the things that are layered into the container. Well, I said containers change everything. I'm going to come back to this picture in just a moment. But what it allows me to do is it allows me to deploy these applications across these different hosts and get a certain level of resilience, for example. And all of these patterns are baked into the platform. You as a developer no longer have to build the automation that's going to make sure that as you have multiple instances of your application for resilience, that you are deploying one on host 1, another one on host 2, another one on host 3. All of that is being taken care of for you by the Cloud Native Application Platform. But then it gets even better. Coming back to this picture is the app team. You're going to give them in that platform the ability to provision and perform any kind of corrective actions. And by the way, containers being so small and the way that we build around them it gives us the opportunity to corrective action is often just throw the old thing out and stand up a new one. It's the proverbial, did you turn off the power and turn it back on? Turns out that works in software really well as well. So you give them that, and I'll come back to the observability comment in just a moment. So you give them all of the things that they need. Gene was talking about it earlier. Architecture matters. So the container gave us an architectural boundary that gave us a level of autonomy. And autonomy is super key. But then remember I told you that I wasn't going to ignore the platform individual? Well, the platform individual comes and says, well, gee, if I'm giving you full control over everything that's in this box, including the OS image, how do I maintain security around that? How do I maintain compliance? Well, it turns out that the platform team, these platforms, a platform as a service, a cloud-native platform, gives you the ability to allow the people who are really the experts in security, compliance, and those types of elements to control the layers in the application that are not the thing that the developer has at the top. The developer controls the application layer at the top, but the platform team owns all of the layers beneath it. So when you have a vulnerability that sits in the OS image, the platform team has the ability to correct that and to roll it out across the organization. Now, how do you do that? Well, it turns out these platforms also embed the ability to have what might be called a trusted container pipeline. So the building of these containers is also controlled by the platform. And I saw Ben Hale earlier. I don't know if he's still here, but he is the expert. He has been working on the Java build pack for building these containers in the Java space for a decade, right? I'm sure at least a decade, right? Yep. So Ben is the person to talk to about this process. And now another thing that I want to point out is that I just talked about the container. The other thing that we want to do is, remember I mentioned earlier cost efficiencies? Well, when we started, I saw this a lot with the organizations I worked in, when they started giving infrastructure as a service, costs ran out of control because organizations would provision their virtual machines and then they would hang on to them. Even if they weren't using them, they would hang on to them. Why? Because they contained information that they might want some later time. It wasn't like the jet fighter where we're going to wipe the thing clean right away. It was we wanted to hang on to that. Well, what this is a picture of is this picture says that what we're deploying into the runtime environment is completely captured in code in a repository. And I think Gene talked about it earlier, that when you have a container and you make changes inside of it, those don't persist. You make changes outside of it in a code repository somewhere. What this allows us to do is it allows us not to hug anything anymore, because everything that's valuable is outside of the container. It's captured in a source code repository. So that's also something that gives us the ability to rein in costs. So these modern platforms allow us to do that as well. Now, let me stop now and step back. So that a lot of that was around self-service and the structures in the platform elements that provide that ability to have self-service. So again, remember, it's not just the APIs, it's the right abstractions, the right units of things that you're delivering, and the contracts that govern that, not just the APIs. But I want to talk a little bit about developer abstractions as well. So first, going back to this picture, is you'll notice that I've color-coded a few things here. And oh my gosh, I just realized that my husband is colorblind, and he probably wouldn't even be able to see the differences. But there's 3 different colors, app A, B, and C. And then I've color-coded some of the containers that are in there. Remember when I mentioned observability? What we want to make sure we do, and what modern cloud-native platforms do, not just infrastructure as a service, but many of the layers that modern platforms layer on top of that, is it allows us to do application-level observability, so that the application developer or DevOps person doesn't have to SSH into one node to get the app logs, and then another node to get the same application logs, but it's just a different instance. All of that aggregation happens on your behalf. So the abstraction that the developer cares about isn't the container, isn't the host, it's not the virtual machine, it's the application that they're running on. And so start to give them the services that they need wrapped against or layered against that application abstraction. But then platforms also do a really significant thing. And here I'm going to go back to the book that Bryon mentioned that I wrote, Cloud Native Patterns. On the inside cover of this book, on the left inside cover and on the back inside cover, is a list of a whole bunch, it's like 25 or 28 different cloud native patterns. Those patterns are things like, hey, you're going to have multiple instances of your application. You're going to, when one service makes a call to another service and doesn't hear back, you're automatically going to retry, because it could have just been a momentary network outage, and on retry, you're going to get back the response that you were looking for. So there's a whole host of these patterns. And as a developer, it's really important for you to understand those patterns. And that's really what I focused on in the book, was helping you understand the patterns. By the way, each one of those patterns taken independently is pretty straightforward. It's how you put them together and the types of benefits that you get when you put them together where the real art comes from, and the real art and the science. Well, there's 2 things that I want to tell you about these patterns. First, I'm going to use one example. I'm going to draw your attention to the very first one here, which is blue-green upgrades. So a blue-green upgrade or blue-green deployment goes a little bit like this. And you'll notice that I left the Pivotal logo here because this is actually one of the slides, one of the diagrams that I pulled out of the Pivotal documentation many, many years ago. A blue-green deployment says we are not going to entirely replace in one fell swoop version 1 of an application with version 2 of an application, the blue version and the green version. Right now, we've got version 1 running. What we're going to do is we're going to very carefully, we're going to deploy version 2, and we're going to have both versions running in parallel. Now, you as an application developer have to know about this, because you have to anticipate in other layers of your architecture that you're going to have 2 versions of an app running. And so that has implications on the way that you build software. You're going to dial that up, and you're going to see how it goes. And if it goes well, you're going to dial it up even a little bit more, and eventually you're going to dial 100% to version 2, and then That'll allow you to take version 1 offline. A pattern like this, there's 2 things that I want to tell you about it. Number 1, it allows you to do something that sounds crazy. It's allowing you to test in production. Remember that comment way back when on the fallacy of the exact replica of production? You know what? I have news for you. You've always been experimenting in production. There has always been some level of risk. And what we're doing here instead is we're saying there is risk, but we are going to put safety nets in place that are going to allow us to manage that risk. And this represents one of those safety nets. Now, the other thing that I want to point out to you here is that as a DevOps person, you don't have to build this pattern yourself. You don't have to build the automation for a blue-green deployment. You have a platform that does it for you. It's baked into the platform. And even Kubernetes, out of the box, open source Kubernetes, has some element of blue-green deployments in it. So these patterns are existing more and more. Now, the other thing that I want to point out to you is going back to this long list here, is again, I said that many of these patterns, it's important for you as an application developer to understand them, but I would say that about half of these patterns exist in platforms or in frameworks, like the Spring Framework. For example, when I said retries, automatic retries, that exists in the Spring Framework. And so all of those elements existed both in platforms and frameworks to allow you to not have to build all those things and be able to iterate very rapidly. So platforms have native support for cloud-native patterns. And when we have and by the way, this is something that I usually say in the beginning, is what do I define as cloud native? I define cloud native as software that is highly distributed. You saw the picture with lots of different hosts and lots of different instances, and it's experiencing constant change. That constant change can be thrust upon the application, or frequent deployments themselves are constant change. And so what cloud-native patterns do is that they're designed for change tolerance, which again is part of the safety net of experimenting in production. So I just wanted to bring us in closing back to this and think about how we're doing. Did we address some of these needs for experimentation, autonomy, and being able to deploy very frequently? I think so. I think these patterns, these platforms are doing that and have proven that. And at the same time, we're still able to maintain security, compliance, fiscal responsibility, and many of those other things. And so with that, I thank you so much. I thank you for having me here. It has been so great. And I'll be here today and tomorrow. I look forward to chatting with many of you. Thank you so much.